back to SocioTech podcast. I'm Kushal, and I have with me my co-host Rupesh, and I'm also very excited to say that today we have a very special guest join with us, Dr. Deepak Nair sir, who is also a faculty at LNM IIT under the EC department. It's a pleasure to have you here, sir.
Thank you for inviting me and giving me this platform to share my opinions and experience with you.
So, as we all know that you have worked a lot in the fields of radio frequencies. So, can we start by you explaining our audience what this field of radio communication is in broad?
Okay, so first of all, let me briefly tell you that I am not totally into the radio frequencies. Apart from that, I do engage with this kind of technologies. I did my masters in RF and microwave from LNM IT itself, and then after that I pursued my PhD in amplifiers, power amplifiers, and it was more about signal processing. And then apart from that, I am interested in both embedded systems and nowadays embedded systems and their applications in AI or ML, and of course bringing the RF domain into the embedded systems and all. So of course embedded systems and RF, these are my strength. So now coming to the radio frequency. So my view about radio frequency, or we can say microwave engineering. Okay, so microwave engineering, if I talk about microwave engineering, then whatever you see around you, whichever electronic device you see around you is directly or indirectly is governed by microwave engineering. You can you name few equipments or devices, electronic devices around you, electrical or electronics, any device?
We can take AC.
AC, any other?
Microphone.
Microphone, okay.
We also have heater and mobile phone.
Heaters, mobile phone. In the background we have a telephone, television, headphone, everything. Even the cord or wire that is connecting the microphone with the PC. So each and everything comes under microwave. How? Let me justify that. So first of all, the AC, you said about AC, right? AC contains coils. Okay, they are electrically controlled, and there are so many coils inside that which generates or controls the temperature. Now the same kind of coils are there inside your microphone also, or condensers based microphones are also there. And of course there are wires which are traveling from your microphone to your PC. Those wires are either parallelly connected or twisted, depends, and data is traveling in those wires at a particular frequency. Similarly, televisions, they are working at a particular frequency. The signals which the televisions receive, be it from satellite or be it from the wires, okay, or all these communication channels contain some data, and they are moving in a very rapid manner, or they are all actually governed by some frequency. So these, whenever you come to a frequency, term frequency, you are directly or indirectly getting into the domain of microwave. Why microwave? Because these, in general, these frequencies are very high, above 30 megahertz, or in general more than 300 megahertz, and these frequency bands are increasing from 30 megahertz to 300 megahertz, and nowadays even we are trying to reach up to 300 megahertz. So all those devices, for example, when you say you are recording a video or you are communicating using a mobile phone, the very moment you talk about a mobile phone, you say, okay, what is your data rate? It is in Mbps.
Bit rate, yes, sir.
Mbps. So the bit rate is in Mbps. How you achieve those Mbps data rate? For example, if you moved from 1G to 2G to 3G and 4G and 5G and maybe 6th or 7th generation, in all these communications protocols or in this communication technologies, basically we are increasing the data rate. So all those infrastructure which are present there, for example, the infrastructure which was used by 1G telecommunication, the wires that they used, the wires they used in 2G, the antennas they used in 2G, the amplifiers they used in 2G are different from those which are developed for 3G. For example, whenever you go for higher bandwidth or higher data rate, you have to develop each and every element for that particular frequency. So directly or indirectly you are moving into microwave. And for example, y- for example, if you take in consideration the basic elements of electrical engineering, resistance, capacitor and inductor, you might be fascinated to know that every resistance in this world, okay, has some inductance in them, they have some capacitance in them, and that is called impedance. The moment you start with impedance, every capacitor for a certain frequency acts as a capacitor. Beyond that frequency, it acts as an inductor, and vice versa for the inductor also. So when you start designing something in electrical domain for any application which requires high frequency, you have to switch into the radio frequency, or you can say microwave frequency. And everything is different in microwave engineering, and therefore I believe it is very relevant to for any electrical or electronics engineer to have fundamental ideas of the radio frequencies or microwave engineering frequencies, or otherwise he will end up with such systems which are good for only for low frequencies, like switching on or switching off. Not only switching on, switching off, even if you talk about a switch, just imagine when a switch is like this, you call it disconnected, right? You bring it more closer, is it disconnected? No, depends what is the voltage at these two terminals. If there are high voltages, they will generate sparks,
Then they will be connected.
they will be generating sparks between them. What is the frequency of those sparks? Those sparks are also of very high frequency, because they are not there for continuous time period. They will just come for maybe some 10 microsecond or maybe some 10 nanosecond period. So that means they are switching on and off at a rate of maybe gigahertz. Similarly, when you talk about the switches in your labs or the switches which are used in the routers, how they support, suppose there are 100 students who are accessing internet, and every student is getting 10 mbps data rate. So 100 students each getting 10 mbps, what will be the switching rate of that switch, and how you design that switch to switch at that high speed? So you have to come up with technologies, you have to come up to the fundamentals of radio frequency, or you can say microwave engineering. So in that perspective, whatever you see around you, electronic devices basically are designed and developed one way or the other by using microwave technology. There are some very simple examples like USB cable 2, then USB 3, and now USB's new upcoming type C cable and all. What is the difference between those cables? Have you tried to think about that? Why the type C cable supports more data rate and more power, whereas type 2 cables, they don't support that much of data rate and that much of power.
As far as I know, it's from the previous generation cables to now we have decreased the number of ports that they have.
It is not only about increasing or decreasing the number of ports, because the moment you say USB, it is universal serial bus. Serial bus means that you will have only 2 wires. You are not going to increase more number of wires for data communication. The wires will be 2 only, but the data rate has increased. If you take in consideration the cables that are used in the LAN, are they the same cable which is used for the microphone, or are they different? What is different in that? Both are developed using coppers. Then what is the difference in the technology that is used for this cable which is connected to the microphone versus the cable that you use to connect a LAN? And similarly, the cables that you use to connect laser or so-called optical networks. So every wire, every cable, everything that you see around you actually comprises of some kind of technology which is there, which is present in microwave. Otherwise you cannot achieve that high data rate, high clarity in the display. There are so many pixels in the displays, right? How you develop such displays which are not interfering with each other? Again, you have to go for microwave. So directly or indirectly speaking, everything that you see around you has some kind of relationship with microwave. Otherwise, you cannot develop anything for high frequencies. It is impossible. Even I can say, okay, let me take a very simple example. You started, or electronic students or electrical engineering students, they generally start with some very basic fundamentals like KVL, KCL, right? Kirchhoff voltage law, Kirchhoff's current law, and all. But why these laws are not seen in the higher, that means in the higher semesters? For example, when you study microwave engineering, you will never come across topics related to KVL or KCL. Instead, you will be coming across topics like Maxwell's equation and so on. With Maxwell's equation, you can derive the equations for KVL, KCL, but vice versa is not possible. So the moment you realize this kind of stuff, then only you will start appreciating that, okay, it is very important to understand the fundamentals of microwave, or you can say radio frequencies. Okay. Even the earth is generating some waves. It also comes under the radio frequency. The light that you see around you, it also is a microwave frequency. There is everything that you see around you, or you hear around you, or you feel around you, is a kind of electromagnetic signal. And to study those electromagnetic signal, you have to have the knowledge of microwave. Even you are, might be possible, you are radiating some heat around your body. It also falls under the microwave. Otherwise, you cannot scan the body using a heat sensor. No. Even in that case, you are using the help of microwave. So everything that you see, for example, this microphone, when you are designing a microphone, the microphone can be directive or omnidirectional. Omnidirectional means the sound will be received from all the directions. The users can sit in a circle, and the mic will collect the sound from all directions. Whereas if the microphone is directional, then in that case only my voice will be recorded, whereas your voice will be not recorded. How you achieve such kind of technologies? You will have to have the knowledge of radiation pattern, polar plot, and all those stuffs. But in general, students think that, okay, this is designed by the company, so we don't have to worry about that. If you want to develop something, then you will have to have a good knowledge of microwave engineering. And right now, in my opinion, this is the so-called bottleneck between developing and developed countries. Developed countries have gained enough knowledge, they have developed enough technologies for high frequency equipments, whereas developing countries, or we can say third world countries, are still struggling to achieve such data. For example, still we are importing antennas, and if you go and check what is the amount we spend to import antenna, just antenna, okay, you will be totally shocked by that amount. How much money we spend to import antennas. Leave around all the other things like the switches, the routers, PCBs, the PCB for the microphones, the PCB for the motherboard, displays, everything. Keep everything aside and just go and search how much money India spends to import antennas. And by knowing that amount, I believe every engineer will try to develop such antennas. And if you see the margin they generate by selling these kind of technologies, it is huge, very huge. Even now we are importing radars from Israel or America. We are importing these technologies related to guided missiles and all those stuffs. 5G equipments, 99% 5G equipments are imported. Not only 5G, 4G equipments also. But if you check the amount we pay for them, it is very shocking. Not only billions, not in hundreds of billions, you will cross all those limits. So, being an engineering college, and when the world is so small, we have internet and all those stuffs. So, knowledge is not the barrier now. Only thing is to produce those precise devices or precise technologies. And by that time, because what I see from here now is that India is a very good country for software related no
Yes, sir.
technologies. But when it comes to hardware related technologies, we are still dependent on other countries. And what are those hardware basically? Those hardwares are not just LEDs or switches. We are good in producing the electrical switches, right? We have many companies which develop wires, cables, electrical switches, bulbs, and all those stuffs. But what about those countries, technologies which are related to developing PCBs, antennas, motherboards, components, even components? So still we have to go too far to achieve such technologies. So if we can achieve those technologies, then of course we will be making much cheaper products for the world also, not only for India but also for the world. So the difference between India and Chinese market, Indian and Chinese market, okay, is these technologies. And microwave is the solution. If you look into that technology, then you will say, okay, if we can develop things around microwave devices and technologies, then only we can develop products. Otherwise, wherever the institutes or organizations are pumping their money, okay, are not going to benefit that much. Okay, so you have to, or we have to go in that domain or direction, microwave engineering. So that's my short introduction about microwave.
So you also mentioned that India is still lacking when it comes to hardware equipments, and as we all know that India has so many colleges, and almost every technical college has EC branch and some or other person working on microwave. So what could be the possible reason that we are still so far behind?
The first reason is that, okay, if you see, are you electronics engineer?
No, sir, I'm not. Yes,
you are not from electronics domain. You are from electronics domain. So in our institute, if you consider our institute, what are the four major domains in electronics engineering? Embedded,
radio frequency,
RF, okay, VLSI,
and
communication. So in communication, we have a group of faculty members who are doing research in communication. There are faculty members who are into embedded, there are who are into VLSI, and there are who are into RF and microwave. Let me broadly differentiate these four domains to you. Especially this will be very helpful for the students also, not only to gain knowledge but for their future goals and also jobs, careers and everything. Okay, how I see these four domains. First of all, communication is related to passing the message from one end to the other end, and the technology that they are developing is to how to accommodate more and more informations in one particular packet. So when you start studying communication, you start studying about modulation schemes like amplitude modulation, then frequency modulation, and then you keep on going for higher modulation techniques that is more or less mathematical. So the more you get into communication, you are more into developing algorithms to accommodate more and more bits in one particular message. So for that, you don't have to rely on too many hardware equipments. Even if you are good in maths, you can work with those algorithms, and with MATLAB or MathWorks other softwares, you can develop algorithms and test them, their efficiency and all those stuff, provided you are believing that all the hardware will be supporting such technology. So you can develop your career in communication provided you have good knowledge of mathematics and if you are good in handling MATLAB. Now coming to embedded. Embedded is not about just developing algorithm. So whatever algorithm these communication engineers have developed, that communication algorithms has to be deployed to some hardware which should run them. For that they will use either VLSI technology or embedded systems. So for those embedded systems, these engineers okay, who are working in embedded or VLSI, they can still study or do their research with one particular microcontroller board, or maybe one or two microcontroller boards and an FPGA board, or maybe one or two FPGA board. So first, the communication engineers who are having MATLAB, they can survive. So one university can pump somewhere around 5 to 10 lakh rupees to procure these licenses, and communications engineering can survive with that also. Now coming to embedded engineering, the microcontroller boards will cost you some thousands, maybe 2,000, 3,000, or maybe maximum 4 or 5,000 rupees for STM's microcontroller boards. And FPGA boards will cost you some few that means hundreds of thousands, that means 2 or 3 lakh rupees. And you can start developing your algorithm and test all those communication protocols in them. So investment still is not that much. Try to think from the perspective of the university. So even small colleges can pump 5 to 10 lakh rupees to develop such labs. Right? Now coming to microwave. The moment you enter into the microwave world, you will have to procure basic 3 equipments. For example, you have gone through basic electronics lab, right? To start a lab in electronics, you have to have a signal generator, okay, function generator we can say, a DSO or CRO to measure that equipment, and then of course power supply, and then some components, and you can start your lab. So this lab will cost you some, again, few hundreds of lakhs. That means maybe 10 or 15 lakh rupees, you can support 30-40 students. Now coming to the microwave domain, the moment you try to purchase a spectrum analyzer, okay, for signal generator, if you go for purchasing a vector signal generator, that will cost you minimum, that means if you go for 6 or 7 gigahertz, I am not going to 300 gigahertz, 6 or 7 gigahertz, or we call it sub 6 gigahertz band, it will cost you somewhere around 20-25 lakh rupees for one
device,
single signal generator. Then this standalone device is not going to help you. You have to measure them. So for that you have to have an oscilloscope. Instead of oscilloscope, you will be using spectrum analyzers. They will cost you some 30 or 40 lakh rupees, one single instrument. Then to measure the properties of amplifiers or antennas or so, again another device is used which we call vector network analyzer. If you go for 10 to 15 gigahertz of vector network analyzer, you can end up with 60 to 70 lakh rupees for normal vector network analyzer. I am not talking about high end. So to establish one small test bench, right, you will have to purchase signal generator, spectrum analyzer, VNA, vector network analyzer, okay, and of course some software to support them. To establish a single test bench, you will have to spend minimum 2 to 3 crore rupees. Because I have not taken into consideration the components. In normal lab, a single resistor cost you 10 to 15 paise. 10 ohm, 15 ohm or 100 ohm 1k resistance cost you 10 to 15 paise. Whereas the similar resistances for RF will cost you hundreds of rupees. If you design an amplifier in a basic lab, you can purchase BC547. It will cost you 5 rupees. If you try to develop a microwave frequencies amplifier, it will cost you 9 to 10 lakh rupees. You can just now open a DigiKey, which is one of the good website which provides hardware and all. You can check the prices. Even our cables will cost you lakhs of rupees, 1 meter cable. And to spoil that cable, it just requires a wrong experiment, that's all. Everything will be getting spoiled. So this is the bottleneck. So it is not that, it is just like you can become a driver. For that you can buy a Maruti Alto also by just spending 2 to 3 lakh rupees. But that will not make you a driver for a Ferrari. To drive a Ferrari, you have to have that knowledge, you have to have that experience. Otherwise, a scratch of Ferrari will cost you more than tens of Wagoner or Alto. So this is the difference between these technologies. This is the difference between these technologies. So to enter into microwave domain, you cannot start it in one day. It is not that you just bring the money, push it, and things will start working. No. In 1 day or 1 year or 5 years, you cannot start or work in the microwave domain. You have to have very good engineers to work on them. And due to this, 99% in Indian institutes lack such facilities, microwave lab facilities. And those engineers who are coming out of those institutes,
Do not know.
they are good for nothing because they don't know how to work with such complicated instruments. It is not the fault of the student, it is the fault of the overall system. If you are actually interested to bring such kind of engineers who are relevant for the industry, no, then you have to bring or you have to pump such money. And if you take the infrastructure of any institute around you, in not only in Rajasthan, go to any other institute, or even the new IITs, most of the IITs, you will find that, of course, the engineers are there, but students are not given the privilege to work on those instruments. Why? Of course, there is a constraint.
Cost.
Yeah, the cost wise. If you destroy a CRO, it will cost you 60,000-70,000 rupees. But if someone comes and destroys a vector signal generator, or for the namesake, the vector network analyzer, it will cost crores of rupees. How are you going to deal such issues? And that's why these technologies are very difficult. You go to any institute in India, you will find almost all the institutes in India, have a good computer lab. And in your opinion, how much amount or how much money you have to spend to develop a computer lab?
It depends. If a single PC station costs about 80,000 and we are having.
Do you think 80,000 PC is installed in any lab?
Well, if they are building
Desktop, 80,000.
If they are building now, then it might. In early days, it might not.
Not if you 80,000. Desktop will cost you maybe 40, 45, 50,000. i7 with 1 terabyte of hard disk and 16 GB of RAM will cost you 40, 45,000 rupees. Don't compare with laptop. I'm a very practical person. That's why I'm talking about these numbers. Understood? So a PC will cost you maximum 50,000 rupees. 7,000 rupees for SSD. 1 TB. Okay, motherboard will cost you somewhere around 20,000 rupees. Okay, assume 15,000 chip, the CPU. Okay, monitor will cost you 6 to 7,000 rupees. A keyboard and mouse will cost you 300 or 500 rupees. That's all. So even if you spend 50,000 rupees, you can install one PC. If you spend, if you want 10 PC, you can just you can just have to invest 5 lakh rupees. 10 PC, 100 PC means you just have to put 50 lakh rupees. And with that 50 lakh rupees, I cannot buy a vector network analyzer. Just imagine the difference.
Single vector network analyzer.
It is just like, okay, let me give you another analogy. Okay, have you seen the weighing machine the vegetable vendors use? What it costs?
I don't know. It should be fairly less.
500 maximum, 500 or 1,000 rupees maximum. Okay, the manual one. Then the weighing machine that you see, electronic weighing machine that you see in the shops for the fruit vendors and all, electronic weighing machine, how much that will cost?
2,000, 5,000.
Maybe 5,000 rupees approximately. What is the weighing machine, or what is the cost of weighing machine which is used by the gold sellers?
That should be expensive because.
20.
How much?
50,000.
I don't know, because that's the problem. Now, what will be the weighing machine, or what will be the cost of weighing machine which calculates or weighs the amount of a particular salt for a pharmaceutical company, or which actually weighs the amount of molecules or atoms?
Should be in lakhs. Of
Lakhs?
crores.
You
Lakhs
think
of
so?
crores.
So every instrument is weighing. What is the difference? The difference is the precision that you want to achieve. For that, any country, any small country can make this kind of weighing machine, but every country cannot develop weighing machine which can weigh the atoms or weigh the gases. So that's the difference. And if you want to make money, you will have to spend money for that technologies. That's the basic difference. Any other question related to that? Huh?
No, sir. Like you given a really good overview of
Hmm.
the microwave RF domain. So what I got to know from that is that microwave is a domain where we play in the frequency domain in the given spectrum of the frequency range. So now, so what motivated you to take electronics and more specifically RF and microwave?
Okay, actually speaking, let me be very frank. I was not motivated. Okay, I was not fascinated that I have to go into microwave domain. So after doing my engineering, I was good in programming, computer programming. Why computer programming? Because like I said, like any other student who has not seen such instruments or who has not worked with vector network analyzer, signal analyzer or so on, he will be having alternatives. And what is the best alternative?
Computer programming.
Computer programming. Why? Because you can just spend 30 or 40,000 rupees, install a desktop PC on your room, in your room, and you can start programming. So you don't have to spend money to learn something. So in my beginning, when I started engineering, I was also very good programmer. Okay, so I actually wanted to work in the software domain, and then after completing my engineering, I went to Bangalore, and there I was living with two colleagues who were in Infosys, and I saw their lifestyle, and I found it very unpleasing that this is not the way I want to live, because their life was very hectic, going in the very early and coming very late and so on. And then I found that sitting on one particular place for 8 and 9 hours just looking at a screen will not be that great. So I was always passionate to design and develop things. I was more into cutting, drilling, making stuffs. So software definitely was helpful, but it was not going to help me for a long time. So I was not passionate about that. Some people find it very passionate. So for me, I was more inclined towards site based works. That means where you go to the sites and do something, labs kind of stuff, where you can move around and play around the equipments and all. So core electronics, you can say. And unfortunately at that time also, 2007-8, I am talking about that time, even at that time there were not many companies who were recruiting engineers, electronics engineers. And of course there is a shortage of electronics engineers positions in India, because we don't have manufacturers. Like I said, you have to invest a hell lot of money to start an electronics company. So I got an opportunity. One of my friend told me that okay, there is a researcher's position in LNM IIT, and why don't you give an interview? So I came here, gave the interview. After 3 days of interview, I was selected for the position of research cum teaching associate, and I started my career in that domain. And I was more inclined towards analog electronics rather microwave or special. Then later, after 1 year, I was introduced to Dr. Tomar, and because my guide was in RF, I moved into RF. And then when I moved into RF, I found it very fascinating, because the moment you start connecting the dots, you will end up in microwave only. Anyone, whosoever be the faculty in electronics, if he want to develop something, a prototype or hardware, he will come across RF. You cannot escape RF. Be it a communication engineering teacher or student, be it embedded engineering student, be it VLSI related student, or be it RF, everyone will have to come to RF. Your algorithms have to run very fast, and that switching will take place in the hardware only. And those hardware will be developed, or you have to have at least the knowledge of those hardware. You cannot just run the codes. You have, if you want to develop something, that's the most important thing. So you will have to end up in having some knowledge of microwave engineering. Otherwise, everything that you see around you is influenced by RF. So that was my journey for the RF and microwave. So it was not that I was actually interested or focused to become an RF engineer, because like I said, 99% of the students in any engineering college, they don't like RF or microwave. It is a blunt truth. Why they don't like RF or microwave? Because whatever they are taught are just equation based stuffs, which any physicist, a good physicist, can do. But engineer and physicist, no, there is a difference between these two terms. Engineers, they develop things. Otherwise, if you don't develop, you are still physicist, which can work in the paper, on the paper. If you can make that thing to work on real world, then you are transforming from physicist to engineer. So I am saying that every engineer has to be a good mathematician and physicist. But the difference is that physicist equation will not work until unless engineer puts his effort. And for that, students, those who are interested in RF also, if they cannot see or they cannot work with those instruments which are used in the industry, how they can get fascinated? They will never get fascinated. So, for example, if you are trying to develop an LED, okay, you are very much fascinated to, every kid is fascinated by electronic equipments, LEDs for example. So when we see red light, blue light, green light and all those stuffs, right, LEDs, we say, okay, it is very beautiful to see. But how can you develop it? Not only as a person, not only as a company, not only as a country, how can you develop them? For example, red LED, green LED were developed in some 1900s. But to come with blue LED or white LED, it took further 70-80 years to develop these white LEDs. So what is the difference between these two technologies? And until unless you get an opportunity to work in that, why you will be fascinated? You will not be fascinated. Still we are, most of us are operators. We are not developers. And you will only appreciate when you will start developing something. And for development, you have to have those tools with you. You might be a very good singer. You want to become a very good singer. If you are not given that opportunity to get trained in that domain by a good faculty in a good environment, you cannot become a good singer. Just by listening something, you cannot become. Similarly, if you want to become a good cricketer or a footballer, you can dribble the ball in the ground for years and years. Until unless someone teaches you or coaches you in the right direction, in a right platform, in the right kind of ground, you cannot become a good footballer. So this is where I believe most of our engineering institutes are lacking, or lagging, we can say. The difference between Indian institutes and institutes in abroad is that there they give more priority or emphasis to the product, real world product that you develop. Here we give more emphasis to the equations that you develop. So even after 4 years, when you go back and think, okay, what changed in my life after completing 4 years? I was doing the same kind of equations in class 10th, more complex equations in class 11th, further more complex in 12th, and then after that further more complex equations in engineering. But what is the difference? Where was my dream or goal to develop something? Because engineer means someone who develops things. So if you are not provided that platform, most of us, that's why by choice or by constraint, they end up in software engineering. That's the problem. If you are not given Ferrari to drive, how can you become a Ferrari driver? You might be a very good driver in Alto. You can spend your whole life driving the Alto, but you will never become a Ferrari driver, because you were not given the chance to drive the Ferrari. You want to become a pilot, Unfortunately, you never had enough money to drive or to take a flight or fly a plane. That's not because you were not interested. That's because there was no such facility around you. So this is what actually differentiates normal colleges with elite colleges. You know, you might be fascinated to know that in Europe, I found that many students, not many, most of the students, they complete their theoretical courses, but they cannot complete their engineering. Most of the students, they fail in their major project, not only once but twice, thrice, four. That means they keep on failing for several years just for the final project, BTP. And tell me how many students fail in BTP in any Indian institute?
Almost none.
None. How many students fail in laboratory related courses?
Almost none.
Almost none. Why? So that means everyone is perfect in designing everything. It might be I can write an equation and I can prove that this amplifier will work. But if I have not seen the battery, if I have not seen the power supply, if I don't know how to connect them, if I don't know which IC to be used, how can you develop an amplifier? No, not possible. If you don't know how to use multimeter, oscilloscopes, signal generator, and unfortunately these are the things which engineers should use, but we end up using most of our time on the pens and papers. We draw the plane and say, okay, if this plane take off with this speed, with this inclination, it will fly. But do we have the facility to even design a simple plane? No. So then that means the things will work on paper, and no company wants engineers who develop things on paper. That's just a fascinating story, or you can say it is just your imagination. This is the difference. This is the major difference, and this is why I believe most of the students move away or run away from microwave. It's not because the subject is not beautiful. The subject is damn beautiful, but unfortunately these students are only encountering such complex equations. They never see things working around. Every student wants to develop drone, but no student knows how this drone is communicating, at what frequency, what bandwidth, what data rate. Where are the coordinates of the drone in the 3D environment? So for that he has to be provided with facilities which he can use to develop. Unfortunately, most of our time, 80% of our time, is spent around theoretical subjects. So this is one of the bottleneck. Why engineering students are mostly confused. In my time also I was confused, and why we end up with such industries where we actually don't want to work. Like I said, it's not about the passion that you were following. Sometimes it is the constraint, or sometimes by choice. But by choice, most of the time, most of the students are not working by choice, because you don't get that much opportunities to work by your choice. You're forced to follow some systems which are there already installed. In India, we don't have that many chip making companies. We don't have that many robotics companies. We don't have that many EV related companies. Of course they are coming right now, but China, Japan, France, Italy, they developed these kind of technologies 40 years back. 40-50 years back they developed it, and we are yet to start. Try to understand, we are yet to start. Understood? So that's the difference. You can become a very good coder. You just spend 40,000-50,000 rupees and you can become one of the best programmer in the world because of your passion. But if suppose he want to become a very good RF engineer, just by his passion he cannot end up to become a very good RF engineer. Passion is not the only thing which will drive you or which will make you successful in that domain. For that you have to have the facilities. And fortunately in our institute we have all the facilities with us, okay, which I believe most of the universities don't have. But our students, again, I don't know what is the disconnect between these students and don't see that many students coming to the labs. They believe that okay, most of the jobs are in the software domain, or maybe they find it easy to find a job in RF domain. Software domain. Okay, so there is one more important thing which I would like to share with you in terms of the careers perspective. There is always this is very simple economics, that there is a demand versus supply. Okay, principle of demand and supply. So in our country we have huge supply of software engineers. Of course the demand is also there, but provided, if you see the trend now, the advent of AI, ML and all those technologies, that the demand is going to slowly decrease. Unfortunately the supply is not going to decrease that fast. So the demand is slowly going down, but supply is still very high for the software engineers. So you will end up with products which will not be sold out, or software engineers who are not getting recruited. This is a very simple equation. Now if you look the other way, the same supply and demand, there is a huge demand for technologies which are related to RF and microwave. Like I said, mobile, laptop, pen drives, television, defense, medical equipments, everything, right? Radars and all stuff, guided missiles, even the X-rays and all those stuffs are governed by microwave engineering. And unfortunately the supply is very less. And if I talk about the demand, if you go and see the demand in UK or any other country, there is a huge demand of RF engineers. Unfortunately we are not producing that many engineers. And let me share you one good data with you. All the students who did BTP with me in the RF domain are either in US pursuing their masters, okay, or are placed in core companies in microwave itself. Some of them working in defense, some of them working with very reputed companies like Qualcomm and all. So it is not that they are not getting job. All the BTP students, I am saying, not a single BTP student who worked with me in RF domain is placed in software company. No, they are all settled in US, or maybe absorbed in defense or that means paying jobs in India itself. So it is not that if you follow RF you will not get job. Unfortunately there is this gap is there. Students are not convinced yet. They are not convinced that they can get good jobs in RF. Might be we will have to. Right now we are conducting some workshops and all to engage the students in RF and microwave. And in future we expect more students to come and join. So and if you want to keep it as a quote, I can say RF and microwave will be the last domain to be influenced by AI and ML. The last domain which will be influenced by AI or ML will be RF and microwave. Most of the domains have already been influenced. You don't need coding and all those stuff. There are the AI is generating much better codes than we can develop, right? So but yet there are not good solutions generated by the AI in RF or microwave domain. There is a huge scope. Okay, so and coming to the salaries and all, like I said, if there is less supply, huge demand, you will get a huge salary also. So you are compensated more in RF domain compared to any other software engineering. So this is my view and my experience, and you can compare that with the data which is published around the globe. Okay. Any other questions if you have?
Not that much, but I am very fascinated by the RF domain, and I could not believe that there are not many students in our college who are approaching you or other professors regarding the domain. This sounds a very cool domain, and there is a lot of jobs and prospect, as you have already stated. So I hope that this podcast would help students, first year, second year, or even the upcoming students, to approach you, at least approach you, learn about domains, learn about our labs, and maybe work into the frequency domains.
So no, I would like to extend it further, that it is not that we are only focusing for the students who are within our institute. Of course, our institute or students in our institute are always welcome in our lab. They can access any hardware, software, everything. But I would like to invite all the other members from other universities, be it student or faculty members, to access our lab, microwave lab, and our instruments, and so that we can broaden our horizons for RF domain. And maybe this will help not only the students but the whole RF community in our state, apart from that in other states of India, so that we can cooperate with each other, and start developing things in our labs itself, so that we can produce or serve not only India but other developing nations. That will be a very big goal, but that's how things should start. That we should first look for our students, extend our technology or knowledge to other faculty members or students or nearby institute, and then extend it further to other universities in our state, then further go ahead with countries which can take our help by generating or developing solutions, sharing those solutions via YouTube or any other channel and all, so that they can utilize such technologies or maybe develop something. Okay.
That was a very enlightening session, and thank you for it.
Thank you for giving me this opportunity, and hope some of the students who will watch this podcast will be getting more insight into this domain, and it will help them to, or it will motivate them to join our group or domain and become a good RF engineer and serve the country. Thank you very much.
Thank you, sir.